Hello, I'm Chris. Um, this is Fraser. We're here to talk about modeling, and um, I hopefully this becomes a series. We'll find out, but we're sort of just trying to test the waters right now. It was already hard enough to just set everything up for recording. We're both new to this. Um, but yeah, today we sort of we've been chatting and we've sort of like really wanted to like sit down and like model things together, like model the
Mm.
behavior of software, um, and particularly in the context of state charts. But hopefully in the future we can dive into like live sequence charts and B threads. I think those would be really cool. Maybe formal verification, although I haven't really dabbled too much in that. But at least in the context of state charts, um, one of the things that I think Fraser is like has been on Fraser's mind a lot is like they're like what are the patterns to modeling and like what are the heuristics and um, the why behind why we model something like we do. It's always been more of an art than a science. Maybe Fraser probably has like some thoughts on that too, but it's like there's never been really many like explicit rules about like if you have a bunch of states, like why would you nest them together into a compound state or make them parallel, and all these decisions around modeling, and so hopefully by like taking examples and trying to rework them or model them from scratch, we can try to like get at that a little deeper than we've been able to by ourselves, and hopefully share that with you everyone else too. So that's like a little context behind why we're doing that. um, don't know if you have anything you want to mention.
I think that's pretty on point, and a lot of it's going. Sort of think of it in two ways. One of them is you go from a set of requirements to a model, um, and then between two models, do you know which one's better than the other?
Mm-hmm.
Um, they're two sort of fairly simple questions, but there's a lot of rabbit holes down both.
Yeah.
Um, Especially the comparing models and why you choose one or the other, and that they sort of tie into each other because often seemingly equivalent models will be subtly different and sort of implications for requirements or what your actually behavior, desired behavior of the model as well. So sort of how you choose to model almost determines what you can model as well. So yeah, there's a whole lot to dig into
Yeah.
there, and even just it's really interesting because we've been looking at Citizen Watch, which is the the example Harel uses in that the state charts paper. Even going into that and looking at how he's modeled it has opened up some really interesting um, thoughts and discussions between us
Yep.
about why he's modeled it a certain way and maybe as we could do it differently. So I think that's sort of going to be our main focus today.
Yes, the
And
classic.
that,
The yeah, for those who haven't heard about this, in his 1987 paper, State Charts of Visual Formalism, most of the paper walks through the visual formalism that is state charts, and it's sort of Harel in a very refined way, just walking us through the Citizens Watch, who later someone named Andy who took that same model that you see um, in the schematic and ported it to XState. So we actually have like that Citizens Watch working on the web. Um, but this Citizens Watch is sort of the starting point of state charts in a lot of respects. It is the um, I don't know how to say it, like the it is the like it's like the first it's just one of those like classic things that someone that like Harel ended up modeling. um and yeah, a lot of people, this is the first state chart that they probably looked at. um at least back in the day, like 30 years ago. So what we wanted to do is we sort of wanted to dive into this model, try to understand the behavior that it's describing, and there's a couple that, at least on the surface right now, there's a couple things that has sort of like irked us about how Harel modeled this. And at least in this video, we sort of just wanted to explore what are ways we could simplify this model, what are ways we can potentially model it better, maybe model it worse. I don't know. But we sort of just wanted to explore that space. So yeah, that's sort of what we're gonna do today. Where would you like to start, Fraser? That is the question.
Where should we start? Well, one of the things that got us talking about this was history states.
Yes.
And it's looking at this diagram, I actually mentioned to you a couple of those history states I don't think to be there. It's the ones sort of like an alarm one in the out, plays out alarm one. Alarm one, sorry, not alarm one, update one. Well, that history state. It's know why was like this, but actually what's happening in update one is you're in update 1 hour, and so that's when you can change the hours on the timer or on the watch, and if you press D, that increments it. So what's happening is it's leaving hour, going into history state, which goes back to hour. Purpose of updating is, I don't think you need to do that. I think you can just have an action for the D event on each of these. This is how Andy actually modeled it.
So
I think you know why that actually there.
So Harel sort of mentions this in the paper at some part, and I could bring that up if we want to look at that specific paragraph, but at the time there was no concept of forbidden transitions, and there was no concept of a transition that doesn't leave a state but does an action. And
okay, that will be it.
And right? As a result, like at least when Harel was thinking about this, those two concepts didn't exist. So as a result, what Harel would do is he would, let's say you wanted to forbid a transition, which isn't what these transitions are doing, actually. But if you wanted to, what you would do is you would just have that transition go to a history state, and it go right back to the state that it was in. So that is like a sort of like a workaround that wasn't built into the original visual formalism, that was later added, at least in SEXML, maybe UML. And so I totally agree here. This history state in update 2, this one in update 1, and this one in update are unnecessary. And we should really have a transition on each of these, sibling states that do an action, and we could sort of dive into that if we wanted to. So if we go into displays, and I'm just gonna minimize some of these. What you can see is when we're in update 2, each hour, 10 minute, 1 minute has a specific transition called depressed, and I'm just going to make this a little bigger. And what you can see here is when you press D, it's going to perform some side effect. That's effectively what Harel was doing here. So total agreement. That's a good first step.
Yeah, because it sort of looks a bit scary, all those history transitions, but a lot of them, it's probably worth pointing out that because of how things have evolved, some of the tools we have to model stuff might not actually have been available, or might have been Harel was thinking of doing. So I think that's a good example of that. Going on from there, I think really that what we've been talking about is look at regular beat test,
Mm.
how that is working together, because what's happening is um, can test watch only in some states.
Mm-hmm.
So only if you're in time, date, or update is, will test work, not if you're in stopwatch mode or some of those other modes. So what Harel has done is clustered states that can beep test into regular, and other ones are outside of that. And so that gives you the behavior of test is only active in those states.
Mm.
Um, I have a bit of a problem with this, and we've been talking about this, and the issue is that can only cluster on one dimension. It's basically a hierarchy, and state charts don't allow multiple inheritance. You can sort of actually it's comparable to inheritance in
Yep.
object-oriented programming. Is that any state in regular will inherit the attributes of regular. And one of the attributes here is that beep test is active. Essentially, is the way you can look at it. They're inheriting this property that beep test is active.
Yeah.
Um,
Did I lose him?
Still be here.
Okay, gotcha.
So in a way, it's quite a natural thing to do that if you're just looking at, well, I want the functionality that beep test is only active. But if you ask sort of why is that valid thing to do, I think it breaks down, and even practically it can be an issue. You can see it, actually one way that you can really see this being a bit weird is how the wait state is out dangling outside of regular.
I never liked this this indent in a state. It it always felt off to me why he geometrically positioned it like that. Um, and I think there's something right there.
And the reason is that wait, not you can't beep test while you're waiting is what that is doing. But
Mm-hmm.
it sort of shows how conferring of attributes, essentially via inheritance, is a bit of a blunt tool.
Yeah.
It doesn't really allow multiple dimensions or to exclude a substate from having those properties. So the example I used with you was, imagine there was another equivalent alarm test, was only valid update, time, and
Mm-hmm.
stopwatch, not date. So the question is, how would you use the same sort of scoping Harel used for beat test for that? And answers you can't. It is because you can't cluster on multiple dimensions. You can't
Right.
include update time and date on one dimension, then exclude one of those in another, essentially.
Yeah.
I'll actually send you through this diagram I have, which I think does a fairly good job at explaining this issue.
Yes, I can open that up if you'd like. The thing I wanted to show once this loads, one of the things that was puzzling when we first saw it, where is it? This is the wrong one. This is in his actual paper. Oops. On visual formalism is different paper than state charts of visual formalism. Always important to keep in mind. But one of the things that, and this sort of goes back to that constraint that inheritance is sort of limiting, is the fact that Harel wanted to proposed a possible extension called overlapping states, which I think Fraser has a better mental model than me about this. But what it allowed you to do is it allowed you to group states in multiple dimensions. But the reason it never really picked up, at least I think, is because the semantics are not clear what it means for states to overlap and to be grouped on multiple dimensions. Um, but this is something that Harel thought about 30 years ago, um, which I find really interesting. You sent me something. Yes, we'll open this up. Let me download this. Can I just put this in a browser? That'd be cool. Nope. I'll see. I just want to be able to zoom in a little bit. Where are you? I think this is it. Here we go. Okay. Do you want to sort of walk us through what's going on here?
Yeah, well, if you sort of start at the top left, you can see that states A and B have an attribute in common, which is that they both transition to C when event 1 happens.
Mm-hmm.
And similarly, in C have a common attribute, which is when event 2 happens, they go to A. This is a common example, and Harel often talks about the benefits of clustering to remove these duplicate transitions.
Right.
The issue is that you only cluster on one common attribute. So you could choose to cluster A and B, and that will remove the duplicate event 1. But then the event 2 between B and C, you've got no way of representing that or sharing that behavior, essentially. So you have to duplicate it. Similarly, you can go cluster B and C, share the behavior that they both transition to A from event 2, but then event 1, the behavior isn't shared, you have to duplicate it. So overlapping states were a solution to this, or sort of thought about as a solution to this, where you can have multiple hierarchies at the same time, and you share the behavior between both.
And the question for me is like, what's the and maybe this is why the reason it never really caught on is B. Are you just always in B? Like,
yeah,
at this.
it's really. I'm absolutely not arguing that this should be a feature, because it's really confusing, and
Yeah.
Al actually goes in that paper you showed. He goes into details about what state you're in can be confusing, and also sometimes what behaviors are shared confusing. And this is multiple inheritance
Mm-hmm.
from OOP, and a lot of languages in OOP don't allow multiple inheritance, and the ones that do, it's practice to not use it, essentially.
Yeah. Right.
And there's a reason for that. It's very ambiguous about what is coming from what, and also you actually lose the hierarchy. It's multiple variants. So you actually lose a strict hierarchy, or like a tree. It's not a tree anymore.
Yeah.
There's just a lot of issues with it, but I think the point is that this was recognized as a problem of Statecharts, is being able to share behavior in a hierarchy doesn't always work, and this was sort of one way of getting around it, which probably be more trouble than it's worth. So you're trying to be thinking about how can we get around this issue in other ways, actually.
Mm-hmm. And what this has me thinking about is how important it is to choose what we group on, right? Like
Yeah.
if we had like, I think we'll talk about other ways, mainly through orthogonality. Um, but what this has me thinking about is if you end up in a choice where you have to pick hierarchy, which do you choose? You cluster A and B, or do you cluster C, B and C? Um, and I
In
think
this example, it's there's sort of no
yeah.
choice, but in a real example, there's actually dimension that makes more sense. That there's sort of
Mm-hmm.
a conceptual reason to do it.
Yeah.
Um,
And
I think
and
there would be some cases where it could be arbitrary as well, or no, not clear, and you just have to pick. But
yeah. And that's what we're trying, I think that's what you're trying to get at here um is we grouped on the fact that update, you could only have a beep test when you are in update, when you're in the time, or when you're looking at a date. And that might have not been the correct, or there might be a better way to group these states together.
I think I would consider that a weak reason. There's definitely not really like a conceptual reason. It's just it behaves this way, therefore we'll do it this way. But I
Mm-hmm.
think the example of, well, if you had another, it's actually only in the specific case you can do that, because I don't there might not be shared like another reason to cluster.
Yeah.
But I think could do better.
Okay.
And the weight state is an example of where it doesn't actually really work that well, because you
Yeah.
have to sort of exclude weight from that and end up with this weird. Even just like the regular, just looking at the names of these is a like regular. What does that mean? No real meaning. It's just a pure thing for the sake of having a group. I wouldn't say it's inherent in the
Mm.
problem domain. It's actually a solution that it's what do you say? It's sort of the in solving the coming up with a solution or a model for it has created this idea that doesn't exist in the problem.
Yeah. And that's, I think that to us was both a red flag. Um, the other thing is this orthogonal state for that contains the region regular and the region beat test doesn't have a name, but it's like, what would you name that? So if you look at what Andy did, which I think is sensical, he named it regular and beep. Um, and it's like, well, yeah, what do you name that? Um, I don't know. And I think that's also part of the, like, one of those red flags where it's like, is there a better way to name this, and maybe that naming can help guide the model. um Before we,
Really.
I definitely want to like dive into trying to remodel this section. um Before we get deeper into that, one of the things I want to mention that isn't apparent is what an event that has a hat on it. um in in this case, I believe how it works, and you can correct me if I'm wrong, um, is when you hold down C, you go into this wait, and if you let go of C, you go back to time. But if you hold down C and we're in wait for more than 2 seconds, then you're allowed to update the time. I believe that's how it works.
That's right.
And what that means, for beep test, which is also a partly weird looking, compound state, is what this beep test is trying to say is, if you hold down B and D at the same time, then beep, like, perform the test. But if you let go, then you stop beeping. You stop the test. So just for Eddie, for if that wasn't apparent to how this behavior works, this hat notation means, let go, which is like C was let go, um,
Yeah.
not
Actually, just
just
looking at that
pressed.
tests, the internals of that, you could probably have parallel states, one for B and one for D. When B's is down, the parallel state for B is pressed, and is down,
Hmm.
state for D is pressed, and when they're both down, then you done transition B, something like that. So I think
Yeah.
those internals could be tidied up. Also, maybe like the cool thing about it's kind of does come from the hierarchy is we can actually just ignore what's going on in beep test and just treat it as
Yeah.
the
The black box.
implementation detail.
Yeah.
Um, Pointing out, I don't know about you, and it might be something that could some other factors, but to me it's weird that you have time to go to wait, because you aren't actually leaving it visually.
Yes, that as well. Wait always that was something I had a really brief thought of like a day ago was like isn't wait something you do in time? Like you don't leave time when you're
It'd be
waiting.
worth um, showing that behavior. Watch.
Sure.
So
I
I
need to
think
zoom out.
insert the battery and then down C.
Yeah. Let me just make sure we're in time right now. We could
We're in
just
time.
for anyone who doesn't know how this works. These are all the active states. So we're in regular and beep, and we're in regular dot time. So we are in this state right now. So if we hold down C, um, you can see we don't do anything until 2 seconds, and now we're in update dot second. So we're in. So we will. We. What's important is while we're waiting here, we never left time.
You have to follow it this way if you're gonna sort of the scoping technique.
Yeah.
Um, which is another. So I just think there's a few things, indications that it's not a good model, and that's not to say there's necessarily a better model. That's another thing to point out about this
Yeah.
whole thing is that maybe it's the way to do it, but I think it's worth trying to think about. Maybe we could do it somewhere else.
Yeah. And the reason that like the reason that we think Harel couldn't put weight in this time state is because we've grouped by the beep test. And while
Mm.
we're waiting, the beep test can't happen. That's the tension here.
If you could do that part differently by saying in beep test that if C's pressed, don't do um allow beep test to be active.
Are you saying like an in guard?
Um, Not necessarily an in guard. If you, because I think the reason what this is saying is that if you're in time and you hold down C, you shouldn't be able to beep test. So one way you could actually do that is explicitly just say in beep test have an extra state or some way of saying if checking if C is held down. So you
Mm,
would duplicate that information. So
right.
that would be one way to do it, and then you could have wait B inside.
Hmm. Okay. Do you want to try modifying this?
We can give it a go. And
Okay.
I'm a little there's definitely a trade-off here that we'll see between doing this sort of putting weight inside, which I think is more like semantically correct, but then you're going to have some scattered information, and it'd be a little less clear that beep test wouldn't be active.
Yeah.
But
And
we can give it a go.
yeah, that's sort of the trade off here, I think, that you have with like orthogonal regions is there's
Mm.
there's multiple things that is duplicated or behavior sort of hidden between those orthogonal regions that are communicating that gets lost.
Maybe we don't do that model and we can just say what we've said here, because I think it's reasonably clear what we would do. But I think if we try and solve the main orthogonality issue, we might not have to mess with the weight state like that. So maybe we should go down that sort of main idea we were thinking of.
Cool, let's do it. Okay, so what's our game plan? So we sort of want to get rid of regular.
We need to find a way of essentially having the same behavior where test is only active in the states that we want it to be, but not expressing it in a clustering hierarchy. That's quite limiting. I can actually send you through, because this is what I was just doing before.
So are you thinking beep test is sort of orthogonal in the main set, like it has a higher level of orthogonality?
I think that might be a way to do it. I'll send you through this image, which I think is quite interesting. I think these are equivalent diagrams, and I think we could use this equivalent to do something interesting.
Okay, so you're hopefully everyone can let me make this big. Hopefully everyone can see this. So currently we have this grouping of orthogonality that says you can only be in the beep test in these two states. But there's some tension with that grouping. And what you're saying is if we change that behavior to some kind of event broadcasting to say, when I'm in a certain state, broadcast an event to this orthogonal region to turn it on or off. We're ensured to have the same behavior where beep tests can only be on in certain states, but we don't have this what feels like some kind of arbitrary grouping of states, which means that we have a little more flexibility how we group these states now. Is that sort of what I'm getting?
Yeah, exactly. So there's definitely a trade-off here. The trade-off is that it's less explicit how play states and beep tests are related, because it's through an event. It's not through a scope or a transition. It's through an event, which is a dynamic relation as opposed to a static and visualizable relation. So that's the trade-off. But the benefit is you get rid of this hierarchy issue, and you could imagine just adding on orthogonal regions, and you could have any combination of A, B, C, and D that are on these orthogonal regions to be on or off. And you could just keep adding these regions, and you could have any combination, and that would work.
And I imagine that the behavior of this watch is finite, like not finite, but is done. Like it's not gonna have any additional behavior added in the future or anything like we typically see with software. And so I do see that benefit here where you can say, well, maybe there's more displays that are going to be added to this watch in the future that we don't know of. And we are trying to model this in a way that scales to that future unknown behavior. That's like what the benefit is, seems.
And the loss of not having that sort of scoped region, in this case, I would argue is not high, because as we said, there was really a strong argument for it being like that in the first place. We couldn't even name the state. It was clustering them together because there's no relation to that from the problem domain. It was sort of a solution artifact.
Yeah.
And so I think the flexibility comes at not too much cost.
Yeah.
Case.
That's interesting. Okay, yeah, let's try it out. So so we're actually gonna make. I'm just trying to get my ground here. We're gonna make displays an orthogonal region. Orthogonal, correct? So what we're saying is anytime you're looking at a display, there could possibly be a beep test. And what that means is anytime the alarm is beeping, there's no way to have a beep test. Although we might
Yeah,
talk about this later on, I believe.
I was gonna say, I'm not sure we'll be leaving that like it is, but you could, for the moment, guess displays and make it.
Cool.
Having said that, why is beep test isn't a display that
I think I lost Fraser again because I don't hear him.
did you lose me?
Oh, did you just stop talking?
The only thing I said was I think we would probably put test at a higher level than displays, just because I can't think why it would be this. Why is it in displays? What is it about beep test that's
Oh, yeah, yeah,
bad
yeah.
displays?
You're right.
If you don't have to scope it based on displays, you actually could put it anywhere, and probably level above might make more sense. It wouldn't make much difference to the implementation. But conceptually, test isn't really. It's got some sort of loose coupling between display states. It's not a display state.
Yeah, that makes a lot of sense. So currently beep test is orthogonal to main. That's what we've done. So this no longer exists here. And we have it. So in the beep test, you can be off. And we're going to have an event here that's turn on. Do you have a good name for this? Turn on beep test, and we're just going to go to on. If you have a better name, we could totally change it.
It's fine, I think.
Turn on beep test. And if we're in on, you can. Oops, totally mix those up. Okay, so.
I can make an argument for why it should be different. The name, I don't really care, but it sort of comes down to events versus commands. I guess that language implies a command. I'm unsure whether raised events should be considered commands, seeing as you actually don't know who you're sending them to. Usually a command, I think, would be to a specific sort, like a target. So turn on this ID or send it to an actor. So maybe something like requests beep test on be an alternative. But I don't think it's that big of a deal.
Okay.
But that is an interesting.
The other thing, these two events are going to be raised, which doesn't exist in the language right now. So we will ignore that then. in the future, you will be able to mark events as raised, and that will be enforced with the interpreter or with the engine. But for now, we'll just leave it out. I actually think this is really interesting. I know we just changed one word. Actually, this doesn't make sense. Request beep test on. Is that a better way to word it? Off. Request beep test off. What it's saying is it's saying like what this implies is that this state called beep test gets to decide that, and someone's just saying, "Hey, I'd like to turn beep test on," and beep test could have some kind of guard here saying, "Hey, nope, we're not leaving this."
Exactly. I think, I mean, I've got a little model of raised events sort of being this cloud of events that each region sort of pulls from. And in that sense, like the request sort of gets up, but it's, as you say, it's up to each region to actually decide what it wants to do.
Mm.
And I think that would still be true of sending commands to things. I think it still would, but I think it's a bit of a better conception of what's actually going on. The whole event versus command thing I haven't gone too deep into, but it's an interesting idea that seems to have come out of domain-driven design. And you
Yeah.
name these things.
And it's something we're going to talk about shortly, um, which is we have these we'll get to the alarm stuff because I think there's a little bit to unpack there, but this
Mm.
concept that the display state drives these other regions. So there's sort of like some kind of delegation happening where the display is sort of what's taking in these raw button clicks A B C D, and depending on what state you're in, it's delegating events to other regions. As opposed to how Harel modeled this, which is everything, all these orthogonal regions listen to the same events and are updated concurrently. And with that mental model, like this display state is sort of in command of everything else, which sort of makes sense if you think about it that way.
Possibly makes sense, but how do you think about that plays is driving it, but it's not really reflected anywhere? The actual topology of the diagram doesn't reflect that.
It doesn't. Um,
Because essentially, like, if you have three orthogonal regions and one is driving the other two, there's no reflection of that in the topology because they're actually at the same level.
I think one of the things that's missing from uh, the visual formalism that Harel originally specified is how do you visualize raised events
Yeah.
that you're broadcasting. I think there is a way to visualize it, which is to say, uh, excuse me, which is it's sort of tricky because you might not know, like you don't know if an erased event will do anything until you're actually running the machine, until you're actually executing the state chart. But what you can say is you can say if a certain transition or entry action raises an event, there should be a way to interactively visualize what that event could affect, and maybe that's like a compromise.
I definitely think something like that could be helpful for the
Like
visualization.
it's probably not going to be an actual line and arrow, but there should be some connection if this transition is raising some event to say, oh, these are the transitions that could be triggered from that broadcast, like some arrow or something's highlighting that certain transitions are could be affected by this raised event. I think there's something there that could help connect the two.
Yeah, I think so. I'm not sure about displays driving the other ones being, at least with the current model. I see why, because of the way the dependency is that's the case sort of at the moment, but I'm not sure it's inherently the case. Like beep test, of course, we've kind of been saying that beep test isn't tied to the displays. There's sort of a loose coupling there.
Mm.
Could there be any situation where it goes the other way, where displays actually depends on one of those other parallel orthogonal regions and actually have a two-way.
I think in this case, light could. I think we'll dive into these three: alarm 1 status, alarm 2 status, chime status. That I think these are driven by the display, and you could see those through in guards. So you can only change the status of an alarm if you're in that alarm display state, right? So you could very much I think these in guards very much represent a dependency, saying the display state really drives me.
Yeah, I think so. I think drive's just a strong word because it's a loose coupling, which is why they aren't actually nested, right?
Mm.
It could be an issue if it really is driven. It's really not clear because they're orthogonal. So it's almost that trade-off, I suppose. This could be why, because we're modeling these with parallel regions. I actually often go to for modules like this, and I think part of that is because that often there does seem to be a primary region that actually almost above or commanding place, like the other regions are sort of almost subordinate to it, and that does happen. I've had that happen a few times, and so that sometimes I'll keep that main region as states, and I might split off alarms into modules. I think that sort of captures the relationship a bit more, because that's why I often sort of go to actors rather than parallel regions, I think.
Yeah.
But yeah, I think maybe you could be onto something there. It's
because
not a.
In this case, if we insert the battery, if we get at why this alarm status is important, is because that alarm status could display here. So there will be some kind of bell if that alarm is on or enabled. And so it's orthogonal to the rest of the watch. It's either we always need to know whether it's on or off. But the states are orthogonal, but the way you get transition between them is not necessarily orthogonal. The only time you should be able to transition between these two states is if you're actively turning the alarm on or off. And that's what happens. That's what these in guards are trying to represent. The states are orthogonal because we always need to know whether, based on the display of the watch, whether the alarm is on or is enabled or disabled. But the only way we could transition is in a certain state. The states are orthogonal, but the transitions are dependent. I don't know.
Yeah, I think that's basically. And when you sort of talk through it, requirements, you can only. Actually, what was so D? So you can disable or enable. It's a bit tricky because we do find this also weird, but it's essentially saying that you can only enable or disable the alarm when you're in alarm. Yeah, that it is a bit that whole, because I think we can actually talk about that at some point, that there's that duplicated.
Yep.
We actually came up with a solution to that, didn't we?
You can remove this. I don't think.
I think that's. Should we? Because did you started writing out what we're going to do with beep test? Did you finish off?
No. Okay, so we have beep test now, so that's in the correct space, which is it's in this top level or orthogonality. So we could sort of ignore it now. The only thing we need to do is we have these other states. Let me collapse update. Where we want to say on enter, turn off the beep test or turn on the beep test. So Um, um, that also means we don't need this orthogonal region, so let's get rid of that. And do we even need regular anymore?
Shouldn't do.
You don't think we do? Can get rid of that. And so all we need to do is we need to say entry do raise request beep test. I probably shouldn't do this in all caps. Request beep test on, I think. Maybe there's a better way to word that. Oh, the other thing, should we clean up? So should we request it off when we leave the state, or when we only when we enter?
No, I don't think so, because on the one hand, the fact that it's going off isn't really the property of that state. It's that the next state is it off. And also, if you were transitioning between states that had them on, it would go off on, and that would be desirable because you'd actually lose the states listed under on. Because on beep test, in the on state, you'll have all of the states inside of beep test, which goes from, if you're holding down B and then it beeps. So you could actually, you were cancelling it, adding things inside of on, which in this case might not be an issue, but could be, and it would be different behavior from what we had before. Whereas if you have each state just on the entry, so whether it's on or off, it actually does, I think, replicates the behavior exactly.
Cool.
If that makes sense.
One sec. Time. Sorry, let me just make sure. Yeah, so we always go back to time. Sorry, there's just a couple modifications we have to make. And yeah, we can get rid of this. These paths are something I want to work on, but that's another discussion. Cool. So let me just save this. So now pretty much, if we look at any of these, when we enter time, we turn it on. When we enter date, we turn it on. When we enter update, we should also turn it on, not off. When we enter wait, we should turn it off. I think I mixed those two up. And the other ones we should request it off. So I think we're good. And this underline action, depending on what engine you're using, will raise that event. Does this look good so far?
Yeah. I actually just realized we said you could actually do the same thing for the alarm. I don't know if you want to get into that now. Maybe we should actually just give an overview of what's changed. The viz. Essentially, we've got rid of that regular component.
This moved up here.
Yeah.
That's what happened. And then when you enter these states, they're gonna raise an event saying, "Hey, turn the beep test on," or turn the beep test off.
And also now update time 8, watch and out, all at the same level. Is that right?
Say that again.
Level.
Yeah, these are all at the same level. There is no grouping here, and we could totally talk about that too. We could put weight.
Weight.
We could put weight in time.
Yeah. And so you'd put weight in time, and then when you enter weight, you would turn beep test off.
Yep. Yeah. Do you want to do
That's
that?
sort of and that's the beauty of this way of modeling it, is there's a lot of flexibility about how you combine or on the beep test state, so we can bring that weight state, which we both agree sort of semantically is inside of time, but we're not constrained by this cluster that was preventing us from doing that.
I'm just gonna call it idle. I think. So what's interesting is all these are gonna move down into idle. I don't know if there's a better name for that state.
Yeah, doesn't bother me too much. I'd say idle and wait. Slightly confusing to have idle and then wait, because idle sort of to me is like, oh, nothing's happening yet. Whereas it's almost like normal or regular, right? Much as we made fun of regular before, it almost makes sense. And I've actually been thinking of coming up with a list of. You often have this state, you're just doing the normal thing, in another state where you're doing something different. I've been thinking of coming up with a list of potential names for them just to have on hand.
Oh, I like that.
So often you're sort of making up these. But yeah, sure.
Where are you? Date. Oops. Okay, and then I just need to do this. Okay, so yeah, we could take a look at this. So now time has two states. Go to
Time has two states, and so idle should raise, it should request beep on, yeah, and exactly. So the parent state time doesn't actually have.
doesn't do anything. It's just a grouping.
It's a grouping, but so it doesn't actually confer the beat attribute onto. So each substate is deciding. What the reason they're grouped is because when you're in time and you go between idle and wait, you're still showing the time. So the shared property or behavior is that time played. Given how we've modeled it, is that displays dot time idle and time dot wait. I think that makes sense.
Yep, and in a display, like we're in the display, right? And so we're displaying the time, whether we're idling, or whether we're just not doing anything, or whether we're waiting to potentially go to update.
I always like to do this check. I think of it sort of functionally is sort of like, do the groupings make sense because they're sharing behavior and reducing arrows, and also conceptually, like, is this model convey what we understand of the system?
Yeah.
And I think that passes both the check.
Cool.
The stage.
I think we have the same. I think we have the same behavior. I think after this recording, we'll definitely want to take what Andy wrote and try to model it the way we have. So that will be in a future video, maybe or maybe in our or just not recorded or something. But that will happen just so we can confirm that we've done this correctly. Okay, so I think we fixed. I don't want to say fixed. I think we've modeled this part of the watch in a different way, that makes it a little clearer why things are the way they are.
Yeah,
Um,
Is it's not easy to objectively say something is better than the other, but I think information that it is capturing and conveying is a bit clearer and a bit closer to the original problem domain.
yeah,
And also the flexibility we've already seen, just that we can just nest things without having that restriction.
yeah.
The flexibility for future changes is improved.
And the other thing that's interesting is beep test like really isn't part of the display. Like
Yeah,
yeah, so I definitely get that tension that you were sort of that those based off those sort of rules or heuristics that you were sort of talking about. So
yeah. He does this. He does the scoping in that other visual formalisms paper. Um, the light component. Because the way it is modeled, I'm not sure if the actual watch does this. Is light light will go on almost no matter what mode you're in. Like whenever you're
mm-hmm.
pressing B, even if it's editing things or changing. Um, and so he sort of extended or focused on a part of the watch and was talking about, wow, could scope light to a couple of the display. So sort of what he did with beep test, he
Right.
with light. Um, and it's actually what got me sort of thinking about how to solve that, because I was not that was of strong clustering reason. It was the same as beep test. It was purely like a functional approach, or it was looking at just the desired behavior, but not really semantic model. Um,
Yes.
so this, I think you can actually, maybe we want to go on to the next part, which is about the alarms and how there's this sort of weird
Yes.
duplication going on. I actually think the same technique will improve this too. And I just remembered our conversation. I can't remember where it was because I can't find what we wrote, but display just enable or turn on and off alarm editing mode, but it doesn't have to have all that state
Right.
there.
Like this history state with this on and off state, these are superfluous. That is what this orthogonal region is modeling, and you're sort of just duplicating that.
Yeah, it's a weird history state because unparalleled region knows whether the alarm is disabled or enabled, but other part doesn't.
Yeah.
Because what's happening is, I think this is right. It is if you're in alarm one and you go between off and on, then that enables and disables alarm.
Yep.
That's exactly what's going on. Um, then when you leave the alarm editing mode, maybe you go back to time. You come back, instead of being able to somehow use the information that you're enabled because the parallel region is enabled or disabled, it just goes back to the one it was. And sort of, it's a bit of a code smell, I think, that sort of weird
It,
synchronization.
it's problematic if there's another way to edit the alarm.
Yes.
That
So
that's
it really highlights the issue.
if there's another, and I know these in guards are obviously not enabling that, but if it was the case when there were other when you, if you're able to change the status another way, like maybe alarm is touchscreen and you could just tap on this to turn it on or off, right? Like that's when this history state is problematic because it's trying to sync with this orthogonal region, and the only way you can guarantee that is with these in guards. And if the
Yeah.
behavior of the watch does change, then that's not necessarily guaranteed. And these, like, we already know whether the alarm is on or off over here. So it's just duplicate. So
There's no source of truth.
exactly. And that's what the orthogonality is trying to represent here. in that the history state is duplicating. And so I think the design question for us, the question for modeling, does alarm one raise events to send to this region, or do we still have in guards, but instead of in alarm one dot off in alarm one in alarm one dot on, it's just in alarm one listen to D. So it's like, do we have this control? Is the display sort of controlling this region, or do we have, or is the region sort of determining when it changes? Um, those, I think those are the two options we have here. So let me remove both of these, and while I'm doing that, I'm sort of interested in your thoughts on what option we should go with, or if there's a third option too.
Yeah, I'm just a default don't like in guards. Anything I can do to avoid them.
Okay,
Anything.
well, so why? Okay, so for like, there's going to be other people listening to this. Why don't you like in guards? Because this is something we've talked about. Um, but
In guards, create a. It's worth saying they're not in guards aren't entered as being very desirable, like in Brooks' book advocates avoiding them if possible. Um, the reason is that you couple parallel states.
mm,
So regions that are parallel know about each other, and if you make a change in a parallel region, it affects another one, which is not the point. I tend to prefer events because you can still have the same behavior as an in-guard, but they're not coupled between the regions. It's how do you say it? The problem with in-guards is you have to specify the state by name, by ID.
mm,
It's sort of a similar problem to jumping and positioning up and down levels of hierarchy. You're making assumptions about what exists outside of your area,
yeah.
and it can create sort of a brittle model. Whereas events don't have to assume where the event is going to, which is a lot more flexible.
Okay, I think I'm in agreement here, where it's like, let's just get rid of these in guards, and yeah, like for exactly for the reasons is like, let's not try to couple like these in guards are directly coupling, like deeply coupling different orthogonal regions, whereas raising events loosely couples them. Um, and yeah, so I think I'm in agreement that we should raise
Yeah.
some kind of event here. Um,
Yeah. So my first step would be remove them unless there's a really compelling reason for them, which there might be. I think you and I tried to work out if you could rule that in guards, and there's some cases where it's just a lot more concise, and especially if the in what you're checking is sort of close by in the model, um, or I think there's some situations where you could split a state, so have substates, and then in guards between those, and it's a really cohesive module. Then it's probably okay in some
mm-hmm.
cases, but I think still my default is avoid them. Strong reason to.
Cool. I agree. Um, I'm just definitely struggling on the name of this action. Toggle is a verb, so it's sort of command. It's sort of like, it's more of a command. Um, do you have a good name for the like name of the event that you'd want to raise from alarm one and alarm two? 2?
'Cause. Um, 'cause. 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 Not really. Remodeling, so alarm 1 won't have off and on
Yeah,
states.
so
Alarm 1 basically just allows the D external event to trigger
exactly.
something in the
It's sort of saying when D is pressed, I'm gonna raise some event. Raise, like, I don't know. Maybe we just call it raise toggle. Uh, raise alarm 1 toggle. Something like that.
I think it's fine. It's interesting, sort of. It implies knowledge of what is going on in the alarm regions. It's switching. How else would you do that? The only way to do it really without it would be saying like raise alarm 1, just telling alarm 1 that D's pressed and you're allowed to know about it. Essentially, what's happening is displays region is filtering events, and it's saying that this external event we're only going to forward to you in this condition
Oh,
where
that's what it is.
alarm.
That's what it is. We're forwarding forward depressed.
Yeah, but then again, that doesn't scope it to alarms. So
Yeah.
depress to alarm, and this is kind of where having alarm as a different actor can be nice, because you can send that event to, you're not having to,
Yeah.
you
Yeah.
can actually
Yeah.
send commands to it. That's
Okay.
so maybe
Before we name this, let's go down to these three and figure out what the name of this event should be. Which yeah, right here. So we're gonna get rid of this guard. These in guards are gone. Bye bye. What should the name of this event be?
and the format before would be something like request alarm 1 toggle, or request toggle alarm 1, something like that.
Okay. Because I think it's important that we don't want a generic event here. We sort of want a very specific event to the alarm 1 status.
Yeah. Again, this is one of the downsides of this way of modeling it, is having these raised events that are
Scoped.
the broadcast. Being broadcast, but it's also being targeted at 1 really.
Yeah.
I'm not sure how I feel about that, because it feels like they should actually be being sent specific to the module itself, but the broadcast mechanism wouldn't allow that.
No, I totally feel that tension too. Request chime toggle. Okay. Let me just fill in these events. Because we are really broadcasting to 1 region with this approach. Like that is what we're doing here. Oops. Okay. And I think there again, it's not that this is a better model. It's just there's trade-offs here.
There's an issue that displays now has no idea whether alarm is on.
Does it need to?
If you need to display that, then
you would say, oh, is the alarm status on or off?
Yeah.
Like it still exists and it's still accessible, right? It's just not maybe in display.
You see what I mean?
I don't know.
These I have a few ideas about some of this, which I probably won't get into now. But one way to think about it, and because a watch is so heavily visual, in this case it's not so bad. But even you could still model a watch without a UI, couldn't you? Could model this as a CLI.
You could.
I find this always interesting to ask. If you didn't have a UI, what states and what behavior would you have?
Mm. Because it really focuses on behavior, the core behavior, not the behavior that stems from the user interface.
And sometimes they can get tangled up or treated as the same behavior tree. And I think tags is a sign of this, that sometimes the UI states don't map onto the behavioral states or behavior
Mm.
states, and that's so you do this all the time in a component where you take a state chart and then you do conditional checks on various states and almost construct an implicit secondary chart for visual states.
Yeah,
And
there's a mapping, and it doesn't map well
yeah,
sometimes.
doesn't always map well, and tags are sort of a way around this as well. So sometimes just thinking about, well, if I didn't have to do this display stuff and just had to do core behavior, what it look like? And I think in that case you wouldn't need the alarm off and on in displays. You have displays, might not be called displays. Something it's more like update. You'd have like update states, wouldn't you?
Yeah.
Um,
Hmm.
anyway, not sure where I'm going with that, but
I think there's something deeper here. I don't think we should explore that this video though.
yeah,
Okay, so there's one subtle thing. So I think I'm happy with this exploration of history states. Um, Whether you use in guards like Harel did, or we're raising events. Um, the important thing, we're not duplicating this unnecessary state. I think that's the important part that we were trying to get at. Um, there's something really interesting here though, which is this transition out of out, which is funny to say, but I don't know if you noticed this, but it says if we're transition out of out after we're in out for 2 minutes and there have been no changes.
yeah,
Do you see that? That this last part,
yeah.
there's no changes? That's super subtle. That is super subtle behavior there. Um, and we could talk about how Andy actually ended up modeling it. But that's different than like being in wait and waiting 2 seconds, or being an update and being an update for 2 minutes and then leaving. This is saying there's no changes that happened, and that what that actually means is that there's orthogonality in this out state that isn't being represented in this particular model. And if we want to go into it, I'm just going to minimize these guys because we don't really care about them right now. How Andy modeled it is he has an activity called idleness timer. An activity is a stateful entity that is orthogonal to, it has a state orthogonal. And that's how that's how he's modeling this. We could model this with a parallel state, so we'd actually make state parallel, or I'm sorry, we'd actually make out parallel or something like that, and we'd have some kind of timer state that keeps track of whether, on any input, we're going to go to this we're going to sort of reset everything. Does that sort of make sense? And I don't know. There's something really interesting here that isn't really that is really subtle, because if you model it as an activity, then what that means, and you can sort of see it right here, anytime there's an input, we have to reset the timer.
Oh, gee.
And nothing against Andy. I think he's done a great job with this, and it's a lovely website. I think an orthogonal state would be better, where we actually listen to these events and reset the timer like that, rather than having to perform side effects on any single interaction. I guess technically this counts too, so this might have been on me. Oops.
Yeah, I see what you're saying though. That,
actually, we don't need to reset there. We're leaving the state. Yeah, you could, it adds up. I don't know if you want to, what your thoughts are about that, because we haven't talked about this yet.
Oh, I hadn't actually thought about it.
So just gonna.
It's definitely a red flag. Sort of had all those action. You could imagine on a big machine just being really verbose.
Yep.
It sort of, it doesn't quite capture, and I think what you said was a better. What's really happening is anytime something happens, we want to reset the timer. So there's two ways you can do that. You can go find every place something happens and do the reset timer, or you can actually make something just that is dedicated to listening to anything.
Yep.
And split that out. So what you could do, I suppose, is you'd have this orthogonal region. I guess it would have to be top level, because otherwise you might be missing out on events.
Do you think it should be in chime? I mean, out, like a region in out, right?
Yeah, so it could be an out. Could be an out. And then.
So we'd have some state. Oh gosh, I don't even know what to name it. So we'd have some kind of timer state, and that would have an initial state. We like there's like this reset that happens. So I think what we need to do, we have a reset state. We have a state called reset, and that will, when that is entered, it will immediately go back to this other state, which is whose name I have no idea what to name it, but like countdown or something. Does this sort of make sense? And then we'll have an after 2 minute, go to
complete, or
we after 2 minutes we go to time.
I think I would be tempted to not jump up the hierarchy like that, though.
And then this is my rough thought. This is like one way you can do it. Otherwise, we go to reset, and we reset the timer.
Got my got audio there for me?
Yep. Yeah, you're good. I think you're breathing into the mic a little bit.
I'll stop breathing.
Not what I. um,
What I was saying was, is it sort of transitions up level.
mhm.
I think we could do it a little differently by doing a final state that raises an event.
Oh, gotcha.
Um, and so when it's complete, when the time is complete, it would raise an event that's idleness timeout, and then would transition out of the out state.
So this is so you're saying there should be a final state in timer?
It's some sort of complete.
Okay. Um, and then you're saying on entry do well, we want to transition out of out.
Yeah, so out would have it would listen to the timer complete event.
Got you. Okay.
The reason for that is timer is now actually put it anywhere, and it's not pulled to the structure of its location. You could even swap out timer for a activity,
Hmm.
and that would be the same interface. And one thing that would be interesting was imagine if another region needed to know about this timeout. Um, then they can listen to that event as well.
Hmm.
I think there's a few good reasons to do it, and the general heuristic is that to keep transitions at the same level
Yep.
of hierarchy, and it sort of encapsulate it.
Is leave good? Go to time. So I think this is what you're saying. After 2 minutes, we don't even need a final. No, I guess we should.
I'd probably say like idleness timeout or something, because leave is very general.
True.
Because it's being raised, it's actually going to every region.
Yeah. Oh yeah. This is a lot better. Okay. And then I don't know what the name of this should be. That's one of the problems for this region. State. One of those. Maybe that's a red flag. I don't know if you have any ideas, but we can get rid of all of these guys.
Is the state wrapper wrapping?
It's wrap.
I see.
So it's
So you can have
really
it all
out.
on a region.
This is really out. Maybe we rename this parallel state now. I don't know if you.
I don't think it's fine to do it like this. I don't know if there's a strong reason that the timer is out. The strongest reason is that it's sort of currently only have idleness timeouts and out. So that is, to be fair, a fairly good reason, but you could also have it at a high level, just like at the top level of the watch, and it's all that's saying is that keep an eye for idleness, and then let other regions know if there's an idle time, and then if that's relevant to any of them. Suppose the argument is that in this case you need to start it yeah, maybe it does actually belong in out because it needs to start and you go into out. So having it at a high level, you wouldn't be able to have that sort of resetting without sending events. So yeah, I'm actually in consideration happy with where it is.
Cool. Yeah, I think we just need a name for this guy. So this is out, and out's now a parallel state. And it has a timer, and then it has updates.
Date or edit. Yeah.
Something like that.
Is there an idleness, or should there be idleness timer on updating the time of the watch?
Sorry, say that
Interesting that
again?
there's not. So you see how if you update the alarm or the chime, there's a idleness timeout. If you update the time of the watch,
Mm-hmm.
there's no minutes in it.
It's sort of ambiguous. Like, what does an
No,
update mean?
no? Does it have? It says if it's 2 minutes in update, go back time. Is
Oh,
that the
right
same
here.
thing? It's really interesting.
The schematic is sort of ambiguous. I would have expect it to say in update with no changes go back. That's what I would expect, but it doesn't.
Maybe
Andy modeled it because this is something that I noticed right before we hopped on this call, and Andy modeled update in the same way as this. And I went through and I was like, well, this doesn't say no changes, so I just made it an after 2 minutes go to update, regardless of whether there's regardless whether there were changes within those last 2 minutes.
yeah. I would say that it's likely meant to be no changes.
Yeah.
If it isn't, it would be real weird because you could be trying to set these times and whatever, and then it would just hop you back. I agree that's ambiguous or maybe even correct how you did it there, but actually what I was just saying could apply. Let's just say that minutes an update and no changes. That means is you would need to do the same thing in
The same
states.
timer logic. Are you saying that this should be hoisted up?
Essentially, you could have a module. I think there's an argument for this being connected, like countdown timer stuff. Always just or an activity tends to be quite isolated. You could have you could either invoke it. If it was an activity, you could invoke it in either state, which would be quite nice. I think probably how I'd do it. Another option would be get a top level.
Yeah. Sorry, I was interrupting.
The other option is sort of what we do before, where you make it a top level parallel component region, and then toggle it on and off in the states that you want it to be.
Yeah.
I feel like there's a bit more leaking stuff and having events flying around.
I think you still need this orthogonal state though.
If it was an activity that was invoked out though, that would be the same, right? Be
what we're trying to avoid is we're trying to say on every transition, reset the timer.
If it was an activity, you'd need to forward every event.
Exactly. So you could still make this an activity, and you can say, but you still need this orthogonal state to do this forwarding. You still need to forward any events to the activity in a parallel region. But yeah, you could definitely make this the state the state's an activity.
Yeah, I see what you're saying.
It's tricky.
Yeah, well, so the options would be put as parallel regions. You duplicate them, or you could give them an activity, and then you could invoke the activity, and then forward events. Like, could you? So you need some sort of forwarder, so you could still have a parallel region that's sort of forwarding events.
Right.
So the only duplicated part is the forwarding, or you could actually have a parallel region at the top level that the forwards or somehow is doing the listening, so that you don't have to do it for each individual. Right?
Yeah.
It's definitely less nice like that.
Yeah, there's something tricky about this, and if there's other things we want to talk about, we don't have to dive too much deeper into it. But I think there's a couple of ways you can go about this behavior, but I think Harel didn't do this correctly. This transition is hiding some orthogonal behavior.
Yeah.
Okay, I'm pretty happy with. I think we got something that is a little better, although we might have to update this state to have the same behavior potentially. I'm not sure.
Yeah. I think it's been interesting trying to make some changes and seeing sort of the trade-offs, because it's very rarely you just get a better.
Yeah.
I do like the flexibility in that pattern of broadcast pattern. I think you can also end up some situations where sort of events are flying around.
Yeah, make some things invisible.
Yeah. I'd rather have something invisible that makes sense than something visibly wrong.
Yeah. Okay.
Oh, actually, I say that. Might not always be true, but yeah. It's invisible statically at compile time, but you can actually you can still view the events.
Yeah. Okay. I think the last thing on my mind that I think I want to talk about before this gets too long is alarm beeps. And I know this is something that you have a ton of thoughts on.
Yeah.
So I'm really curious about that. The only other thing I could potentially think of is stopwatch, which the deep history really stands out to me as being orthogonal.
Right.
Similar to the alarms, it's like we have this stopwatch state, and um, that's sort of orthogonal to the rest of the watch, right? Like if you go to the stopwatch, start it, stop it, leave it, come back, right? Like that's orthogonal. And then there's a stopwatch display that should like maybe delegate events like we did for alarm 2 and alarm 1, right? Like we'd probably want to be consistent there. Let's talk about stopwatch and then we'll talk about alarm beeps.
Right. I haven't really looked into stopwatch too much, so I'm interested to see what you're thinking. It's interesting how it does look a weird one.
Like it's an orthogonal state. That's what this is saying. And it's like only when we're in the stopwatch display should we be able to update that orthogonal state. Like, yeah, you could model it as with a deep history state, but I think both of us are like deep history. That's like a red flag for something else going on here, and it's really just that this compound stopwatch state is sort of orthogonal to the displays.
And maybe to explain that, what you mean by the deep history thing is that deep history is saying that we want to go back to where we were previously.
Yep.
But what what often is the case is that you never really left, and if you model it orthogonally, you don't have to have a history state because you never leave the state.
Right. It still
so
exists.
And the difference being is that if you use as a deep history, then leave it and those states won't be active. So if you aren't in stopwatch, nothing can change or mess around with what's in stopwatch. It's not an active state.
Yeah.
Whereas if you make it orthogonal, then it is active all the time, and you would need to actually have some sort of filtering mechanism that we've used before, which is like an on-off. And actually, that's why with beat test and some of those other ones, like alarm, if you move it to an orthogonal region, you need some filtering control. But can often be the case that what the deep history state should be saying is that you've never left, or hinting that that could be an option.
Yeah.
But if we manage to get rid of all the history states on this diagram, will you agree to remove history? It's from the spec.
We'll have to talk about that in more detail. But I would be very interested. It's sort of in this stopwatch case, this deep history sort of acting as a filter itself. Like that's sort of what its purpose is in this particular instance.
Would you maybe be able to just go up to the watch display and get to the stopwatch state and show what's going on? Because I don't really have a good model of what is going on there.
Sure.
I'll if you bring the watch up, I'll tell you what events or what buttons to press.
I think A, and then we got a bunch of
one. A. So yeah, A.
Yeah.
Go to stopwatch.
Now we're in the stopwatch.
So we should be at 0.
Yep. Yeah, we're in 0 right now. Stopwatch at 0, and if we okay. It's interesting that stopwatch has its own display state and whether it's running. Now, one of the questions I have, if we're running and we leave the stopwatch, does this still blink?
Try it.
B. Okay, so we're running and we press A. Where is this being stored? How do we know that the stopwatch is on? I'm just curious. I want to go back. It's still running. We might have
modeled differently. Andy might have modeled a little differently. What is there? Is there
I could check.
Yeah.
So I'm just gonna close out of
You're having a look at that. It's worth pointing out that it sounds really nice that we're taking Harel's watch as a closed system because all the requirements are given. We're just trying to replicate behavior.
Mm-hmm.
And when I've been working on Pac-Man, it's the same. I've been treating it like I can't change the requirements. This is how it is. But in truth, usually when you're modeling these things, you have an influence. You can decide that actually the way to model this could be better, and you actually have a better behavior as well.
Yep.
And often that design is a conversation between people, and it's not just a given. And end up really having to convolute your model to achieve stupid behaviors.
That is so well said. I appreciate that you brought that up so much, because there's so many times when we're like working through like, oh, let's add this enhancement to this app, and it's like, well, this doesn't make sense. And if you really want it, it's just like immediate technical debt. You know. I really appreciate that you brought that up. I think that's a really good point.
And sometimes you will be asked and made to do those things, but um, often it's sort of a win-win where you're like, actually, we can get a better behavior and a better model at the same time. In a situation like this where it's closed, um, sometimes have to really bend over backwards to accommodate,
Yep.
like almost like a not desired behavior,
Yeah.
or unintended behavior.
To me, this is an orthogonal state, which is the stopwatch is running right now, and we need to know that. That's what this is telling me.
It's
I
You can
I'm
even
not.
see it like in the visualization. Alarm 1, Alarm 2, Chime, they're all orthogonal regions in the state chart
Yep.
from stopwatch. Orthogonal at the level of main. So I don't see no reason why stopwatch shouldn't be at that.
Yeah.
Should be orthogonal along with those.
The So if we're running, then we could lap. I just want to figure out this. Cause like, do we need to remember if we're lapping, if we move away? Like, there is some question about that. Cause this is like, Harel saying, hey, this is the display state. Running should definitely be in the background, or like in an orthogonal state.
Yeah.
Yeah, let's figure it out. A. So if we press B, oops, we stopped. We want to press D. So if we press B again, we'll start. If we press D, then we lap, I think. Yeah, we lap. I'm not sure what that's doing in this scenario.
Because usually a lap would be press lap and the stopwatch keeps going, but it gives you the time when you pressed it. So like, it's like imagine running around a track and your first lap you press D, then the next lap you press D, and then you end up with like a list of.
Oh.
I'm not sure how it works. I'm not sure how it works in a display like this where
Yeah, you can only display the time.
It seems like it does exist in the watch, but.
Okay. Yep. Yeah. This is an orthogonal state. I'm sort of sold on that now.
And it probably would be the same tactic we applied to Alarm 1, where you allow editing when you're in the right display mode, but everything else is handled in the orthogonal region.
Yep.
Imagine.
Yeah. Cool. Okay. I'm not gonna like do that right now. I'll do that afterwards as an exercise. But yeah, let's okay. So yeah, one of our big things is been that we've also been exploring, but we haven't explicitly talked about is like, are history states necessary? Do they add some level of expressiveness to state charts? Do they add some level of conciseness to state charts? Like what is going on there?
Or do they just exist in the spec, so it's too hard to remove them?
Or yeah, is it like some kind of tech debt that needs to be brought along? That's like one of the things we've sort of been talking about on the side. So the last,
It's probably worth. Sorry, it's probably worth saying that you have very detailed knowledge both of states and sort of how they were developed or the reasons why.
mm-hmm.
But you also you've sort of two hats because you're working on this spec. Um, you have to be quite careful about what you might include or not, and
Yep.
there could be reasons, like I said, like maybe it's just the fact for compatibility that you might want them.
Yeah.
Because I have no such sort of responsibilities to anything, so I can very sort of glibly say that I'd happily remove them.
I would love to say we should remove history states, because there is this magical underlying mechanism that history states are representing, that yeah, I don't know. It's tricky, but the fact is they've always been part of state charts for the last 30 years, 40 years almost actually, um, and that's the tricky part about this conversation. So what I'm really interested in is we have one more history state to chat about, um, and that relates to alarm beep, and this will probably be the last thing we talk about in this video. Um, and so I think you have a little deeper, a little more vivid picture or vision in your head of what alarms beep is doing and ways we can model it differently that I'm interested in.
A little bit, but
I
I think
haven't
it's
thought too
actually
much
going to
about it.
be
Sorry.
it's going to be I suspect similar to what we just talked about.
So you think
We don't
alarms
have
beep
to
should
do
be
this, but
orthogonal?
well, when you set an alarm and an alarm goes off, say, okay, let's walk through it. So actually set an alarm because it can be hard to line them up. But if you set an alarm in the watch and you're happily reading your time on the watch and the alarm beeps, what happens is the little icon starts flashing.
Mm-hmm.
Um,
But you're
but
still
you're
in the
still
same
staying
state as you were.
in the time state.
Yeah.
And that on its own is like, well, if you look at this diagram, you leave all the display states.
Mm-hmm.
And that to me is another indication, sort of along with the deep history, because deep history is saying, well, whatever caused us to leave and go to alarms beep, we actually want to go back to there. So that's where I'd reframe that and go, well, did we really ever leave? Did we leave time? And you look at the watch and you didn't leave time.
That's really interesting. There is something interesting here though. So I think what you're proposing, alarms beep should be an orthogonal state in main, and there should be another state like off. And when and there's events going from T1 hits T hits T1, T hits T2, and T hits T1. That goes from off to these three states, and then these states go back to off when these things happen. That's sort of what it seems like you're saying.
Something like that. Did we draw something about this? Let me just have a quick look.
Okay. The reason this is my take. The reason this can't be represented as an orthogonal state is because you want to be is because of this transition right here. On any button press, go back to display. Because what we want to do, we want to say it doesn't matter what state you're in. That might still be rendered in the display on the display, but what we want to do is we want to restrict all possible events, and the act of pressing a button lets you go back to where you were. Do you sort of see? Because if this was an orthogonal region and you're in time, then if you press C, then the alarm goes off, but you also go to wait, for example. I think that's why Harel.
I think that so I think you're nail on the head of why it's like that is because you leave displays. One of the events that displays listen to, like B, C, or D, are active, and all you want is that a button press will basically cancel the alarm. I wouldn't go as far to say you can't do it, but I could also just say to you, like, how is this even possible model that works? Because you're in time, but you're not in time. Like, does that even work? You know what to display.
That deep history.
But and when the alarm's beeping, what are you displaying? Because the watch shows whatever state. Well, at least when you're on time, it will show you the time. So, unless it goes to a special, unless you say alarms beep is a special display, which is also the time display. Maybe if an alarm beeps and in stopwatch mode it goes to the time. Maybe that's what it does.
Do you want to test it out?
Yeah, we just need to set an alarm. I'll do it on mine as well because we two people will have a better chance. What is the current time? Okay.
I always forget. C sets the time. C. Okay, so we're gonna turn this, and we're gonna go to C. We're gonna C. Oh man. Oh, I'm gonna remove the battery. Okay, so we are almost at 12. So we're gonna go to A. We're gonna go to C, and then we're gonna go press B, and then we're gonna press D, and we're gonna press A. Let's hold down C. Let's get into an update state. And then press C. Okay, so we're just going to be in update state for like a minute or something. I might have put the alarm on at like 12:02 or something, so we have a minute.
Worked out a speed run for it. If you A, D, A, remove the battery, then it works.
Okay. B, A.
You gotta remove the battery.
It's too late. It's too late.
If you remove, is it coming up in a minute?
We got 40 seconds. Let me just CC. Okay, so we're editing. Let's see what happens. We got 30 seconds. That's the thing about history states is there's always some orthogonality that occurs with them. But there's also this like event filtration
exclusion.
or selection. Yeah.
Orthogonal. If you're orthogonal, you're in both. But if you're history, then you can not be in one.
Yeah. Let's see what happens. Oh, do you see that?
Yeah.
Let me...
It's any button.
Then we go back. So it brings you out of this state, and it just shows you the time.
So I was wrong about that. So one of my sort of key reasons for not liking it was I thought that you stayed in time, but you actually go to this different visual state that happens to look very similar to time. Does not, and then you go back. This is going to be the hardest one to get rid of.
There's also something about alarm beeping rather than it beeping here or something. I don't know. I think this one is necessary now that at least based on the current behavior.
Not sure about necessary, but possibly best way to model it. But what you would need to do if you wanted it, have a history state and have it be orthogonal, would be event filtering. So all those B, C, D events would have to go through the orthogonal component first, and that would decide whether to allow them through or not, which is a little nasty. Maybe not ideal.
What that means is all these are raised events. That's what you're saying. this is a parallel region, and depending on what state it is, it's going to broadcast certain events to the display state. And all of these are really raised events.
You were talking about before, like displays kind of driving things. This would be a weird inversion where alarms beep
Drives
for
the
some reason,
display.
drives everything else, and that conceptually feels a bit off. The only thing that sort of I would say is this idea of events like A, B, C, and D are raw or external events, whereas phased events are sort of internal or second order or derived. And
Mm-hmm.
there's something about to be said for not processing external events very deeply inside your model and having them you try and process them high up as possible. I think I came across this in the domain-driven stuff.
Interesting.
And the main idea is that you're sort of like the whole thing about levels. You sort of want the lower level things to be at an appropriate level of abstraction, be handling events, and it's a bit less clear with like A, B, C, and D. But there's times when sort of high level events should be handled at high levels of your state charts, and then low level events should be at low levels. So, for example, like a stopwatch events be at fairly low level, and there won't be like a high level on it. Potentially, I'm not coming up with a good example here, but there is something that beat test at its per substate might be trying to read A and B, and that just means it's a bit brittle if you did need to start intercepting events. Is that got all these dependencies events. I'm not saying that sort of means that alarms beep should be forwarding things, but
that's how you would model it.
Yeah, and patterns we've been describing actually involve sort of event filtering, and that's the way it seems to be in state charts that you can have this flexible behavior. So maybe there is like a deeper heuristic about how you handle that. That would make the orthogonal idea more palatable, and I'm not sure I have an answer for that right now, but I'm not willing to totally say history.
No. I see where you're coming from. There's implications of that though that I don't quite understand yet.
Yeah, well, maybe that's where the people can share some ideas about this.
Awesome.
At the very least, what I'd love is if we could say, okay, here's a canonical example of history states a better alternative. Here's the suggested alternative, and here's why not better. And here's like what's going on in the model, like this idea of exclusion. You've got events that can't happen, and that's why history states are good for this. Even if that's the answer, and say we need history states, and here's why, I think that's really good. And because you can then go, well, you can see that situation in your model, and you can go, okay, history states, this is the
exactly.
And then you can separate it from these other cases where, first glance, it seems history is appropriate, but a different type of orthogonality is way to go.
Yeah, I know. I'm not sure we have an answer right now, but I think the unclear thing about the behavior of this state chart is we have a state dedicated to displaying the time, and it is not clear that alarm beeps also displays the time. That could be a naming issue, or it could be a modeling issue, and I'm not entirely sure. But there is hidden behavior about what alarm beeps is displaying. Like obviously we know that the individual alarms are beeping, but we don't know what's displayed on this main display. And I think that's what it feels sort of problematic. That the model, right, that Harel's model doesn't fully articulate to me. And maybe it's just a description that you need or something. I don't know. Sorry.
You can see like displays. Alarms beep is not in displays, and the reason is so that you can get this going back to the history. So it's sort of like a grouping around all these states, which is like a weird it's weird that it's possible for the watch to not be in a display mode.
Right, but also be displaying things.
Yeah. So and it's where the sort of functionally that you can see why it's happened, but conceptually it's real weird. And when those two things don't match, it's a sign that it's thinking, maybe not changing, but at least understanding why.
Yeah. Yeah, it could be the naming here, but like maybe this should be called displays or something. I don't know. Or yeah, like maybe there's a naming issue here too.
Maybe. I'd be yeah. Let's maybe make that be a take home or a
Yeah,
further thing.
that's your
But
homework for anyone
well,
watching. That's our homework too.
I'm gonna try and get rid of this history state and see what we can do.
Yeah.
Yeah. Good.
Awesome.
Okay.
This is awesome. This is super fun. I hope we find more things to model. Hopefully it's not a pre-made state chart. Maybe we'll try to model something from scratch. I know at some point I'd love to talk through how you modeled Pac-Man.
Yeah.
That gets into a slightly different realm where you have actors talking to each other and stuff. I'd love to dive into that at some point, but
I need to look at it because things we've been talking about have hit some this whole hierarchy, tonality stuff, casting had a lot of these issues. We've really actually sort of identified and come up with maybe some different ways of doing it, and I'd love to go back and if that helps.
No
me
rush,
with that.
no rush.
But maybe we could even do that together as well. But
Yeah.
yeah, so I think there is fairly fundamental tension or going on with some of the things we've been talking about today, and it's kind of cool that they've arisen out of this chart, which is sort of the OG. So that's quite interesting.
There's so much history associated with this state chart, so it was very cool to dive into it. I'll try to I have some things to touch up here, and maybe in the next day or two we'll have some ideas about what to do with this alarm beeps state. At which point I think we will have finished a variation of this state chart that that describes the same behavior. And what I want to do is I sort of want to fork the repo that Andy made. That is over here, and update it with the state chart we have, and see if it works, see if what breaks. So before we post this video, we'll try to actually make sure what we were talking about works. At which point we'll share the video, share the new state chart that we've described. Yeah. So thanks for watching. And yeah, thanks Fraser for the time. It was super fun. I hope we could do this more.
That's good.